Yeah, hello everybody. Would like to talk about climate change and how it has affected the Baltic Sea and how it will be. As yet mentioned, I'm working within a network, a science network, Baltic Earth. It's a network that focuses on Earth system science for the Baltic Sea region. And in collaboration with Helcom, a fact sheet has been produced, and I would like to show you some selected results. The collaboration between Helcom and Baltic Earth is quite long-lasting. The sorry, the first assessment published as a book was already in 2008 with a follow-up in 2015, and very recently we produced the Baltic Earth Assessment Reports, which is a special issue in Earth System Dynamics, so a scientific journal with 10 review articles in this. This material is quite heavy. One of the 10 articles you see here, at least the front page, Climate Change in the Baltic Sea Region, a summary. So what is in that article? The knowledge gain since 2013 based upon peer-reviewed articles. 33 parameters from the atmosphere, cryosphere, land, terrestrial biosphere, ocean and sediment, marine biosphere have been assessed. There's nothing about the anthroposphere, actually. We looked at past, present, and future changes. That means past the last 8,000 years until the next 100 years. 47 scientists put their knowledge together. They read and assessed more than 800 references on 133 pages. If you are interested, or this is publicly available from the Earth System Dynamics homepage, you can download this article. However, it is maybe not, it's written for scientists and maybe for managers of the Baltic Sea less digestible, and therefore this fact sheet has been produced based on this material. Climate change in the Baltic Sea, and it can also be freely downloaded from the Helcom homepage. We have here also parameters. It's actually not exactly the same that in the original article, science article, but a lot of the material has been copied from the article. Well, not copied, translated into short, condensed statements about past and future changes. You see here the list. It starts from air temperature and covers salinity, oxygen, and so on. So also parameters from the biota and the ecosystem in the Baltic Sea. But in addition, that is not in the Bear report, also some statements about human activities like coastal protection or shipping. And as I said, I would like to introduce you into a few changes. So we start with air temperature over land. And here you see different curves from the different seasons, and the different colors of the curves are actually the temperature development over land from the Baltic Sea catchment area north of 60° north, that is about Stockholm, and south of that region in blue and red. And the dots are actually the annual values. So the curves here show the smooth development. And when you look especially at wintertime or spring, you just by eye, without applying any statistical method, you see there's a systematic increase in temperature over land, which is statistically significant during the past decades. This trend is larger than the global average and slightly larger than estimated before. So that means that there is an acceleration in this trend. So it's getting warmer and warmer. And not shown here, but you can also look at water temperature. Then the land is warming more than the water. The the sea surface temperature. This next slide, I apologize, it's in Swedish, but actually the most reliable data from runoff, so fresh water supply to the Baltic Sea, which is a very important parameter, exists only for Sweden. And here for the different regions, one in the very north, the catchment area to the bottom bay, and number 4 is then the catchment area to the Kattegat and Skagerrak region. Are displayed here based on observations, and you see clearly in the north there seems to be also a trend. If you take all the data together for the Baltic Sea, actually you can't see any trend, but it seems that there is an increasing trend, so the more fresh water supply to the Baltic Sea from the north. That should reflect in salinity, because salinity is the parameter that measures in the ocean if we are more in the marine environment or in freshwater, more lake environment. So a very important parameter for the ecosystem and for the physics and dynamics in the sea. Here you can't see any trend if you average together. So this shows sea surface salinity for the past 100 years. There's obviously some kind of oscillations, but no systematic trend that you can see nicely with your eyes. The data are actually the dots, and the curve is some kind of model reconstruction. And neither data sets show any significant trend, which is important and which supports the previous statement that in the overall runoff to the Baltic Sea, we can't see a trend. From the north, yes, but not overall. The sea level is rising, not astonishing. We know that from other stations around the world. 14 Swedish marographs are shown here since 1882. The data are corrected for land uplift. So in the very north, although there is an increase in the sea level by, say, 25 centimeters over the more than 100 years displayed here, is compensated, of course, but not in the south. So what do we expect for the future? Here you see the future air temperature changes. The upper row winter, the lower row is summer, according to different greenhouse gas emission scenarios. To the left is something like the Paris Agreement, and some worst case is the RCP 8.5 to the right, and you see a warming. You see the warming is largest in the northeast, especially in winter, and the land is, as in the historical records, warming more than the sea. And the average temperature, average over the area that you see here, Europe, it's between 1.5 and 4.3, depending on the emission scenario. The same for precipitation changes. This is quite important. So you see here, independent of the emission scenario, some wettening. So an increase in precipitation in winter in the north. In summer, it's less clear. At least the southern catchment area of the Baltic Sea, the sign of the change is a little bit unclear. But for the northern part, it's obvious. So now you ask, of course, what is with the important parameter salinity that I showed you before? For the past changes, it depends on river runoff, the global sea level, because higher sea level means more salt water in transport from the ocean, from the world ocean into the Baltic Sea via the Danish Strait. And then wind is also important because this water exchange occurs sporadically. Without showing you the details, the wind does not change significantly in the projections, but runoff increases, but also sea level. So it is getting fresher from the north and more saline from the south. And therefore, taking the uncertainties of all the different models into account, we do not know what is occurring with salinity. So there's an uncertainty, and that's very unfortunate because, as I said, salinity is a very important parameter for the Baltic Sea ecosystem. Another very important parameter is oxygen. And here you see the curve of dead sea bottoms from 1850 until the future. In the colored, you have different scenarios, and now everything is under a warming climate, but it's also important now to discuss the nutrient loads to the sea, because that controls the oxygen consumption. So that oxygen bottoms are affected very much on higher temperature, yes, but also on the nutrients from the land. And you see in the 60s the huge increase in the bottom areas. That is actually due to the agriculture activities, and also sewage water that has been not sufficiently clean. After the 80s, the situation went much better, but it's still that the Baltic Sea is in a problematic state concerning oxygen depletion. And you see, if we apply an optimistic scenario, the Baltic Sea Action Plan, then there will be a significant reduction in the dead sea bottoms, but not in the worst case or reference scenario as shown here. You can see all this information, or can read it from the fact sheet. This is one slide showing a map, and you have then boxes for each of the sub-basins. You have some information. The parameters are shown here as the symbols, and you can you can read in a concise way what we believe the projections will tell us. What I told you, briefly summarized here, the sea surface temperature is increasing. Correspondingly, the maximum ice extent will be reduced. Salinity, we do not know. The global sea level will rise, and the implementation of the Baltic Sea Action Plan will lead to significantly improved deep water oxygen condition. However, we need really to go on. So there has been a lot of success done already in the past, but that should be continued. Thank you very much for the attention.